Hello and welcome to the Staff Access Masterclass on the Evernym Decentralized Identity Platform. My name is Vladan Divac and I'm a software engineer at a company called Evernym. Evernym is a provider of decentralized identity products, and in this recording we will show how Evernym platform can be used to create your decentralized identity applications. Decentralized identity is often referred to as self-sovereign identity or SSI, and in this video we will use these terms interchangeably. This is the fourth installment in the NHS Staff Access Hackathon Masterclass series. If you are new to decentralized identity, I recommend that you first watch previous recordings, especially an introduction to decentralized identity by Mr. Andy Tobin, since in this recording we will assume that you are already familiar with basic SSI terms like issuer, verifier, holder, schema, credential definition, proof request or presentation request, DID, wallet, ledger, etc. This session is mostly geared towards developers, but if you're coming from non-tech background, there are some nuggets for you too. We have created a web page dedicated to the NHS Staff Access Hackathon. So let me briefly guide you through this website. So from this website, you can register for the hackathon. It will direct you to the INTEROPen page, but I assume you have already done that. And you can directly go to developer resources. But from this side, you can also read additionally about different SSI topics, read our white papers, and watch our past webinars. The last one was an introduction to Verity. This one is more from the product perspective. I heartily recommend watching. And then there are all of our past webinars on different SSI topics. So you can choose the topic you are most interested in and watch a recording. They are approximately 1 hour in length from the leading experts in the field. However, in this recording, we will mostly be interested in this part, Verity developer resources. From here, you have a link to our public GitHub repository with Verity SDK. Okay. And then you have direct links to the different part of this repo, like for our getting starting with Verity step-by-step guide to 3 different SDKs that we support, API references, example apps for different SDKs, the demo web app using our REST API, REST API Swagger documentation, and step-by-step tutorials on how to build a verifier or an issuer app using REST API. Our SSI stack comprises of 3 basic components: Verity application server, that is Evernym multi-tenant Verity software as a service offering. Verity application server, also referenced as VAS, will host an agent for your issuer or verifier SSI app and will route messages between your SSI app and different holders of digital credentials. Then we have Verity SDKs. You can create your SSI app using Verity SDKs. We have SDKs available in Node.js, Python, and Java. And we have REST API available, so you can basically program in any language that you like that supports asynchronous web requests. And the third part of our stack is Connect.me app, that is mobile wallet to hold your digitally signed credentials. Now I will guide you how to install and set up your Connect.me app. If you don't have Connect.me app installed, you can download it and install from Apple Store or Google Store. So if I go to Store and search for Connect.me Evernym, I will get Connect.me application, this one with the green logo, and I will have the option to install. Since I already pre-installed this app, I will just click on Open. When you're first time opening the app, you will be presented with end user license agreement that you would need to accept. And now we are coming to an important screen. At the bottom of this screen is a toggle Use Staging Net. For this hackathon, you would need to turn this toggle to on. So I'm now doing it so that it is green, like presented now. This button determines whether Connect.me will be using Sovereign Staging Net when this button is turned to on, or will be using Sovereign Mainnet when this button is turned off, which is default position. And it is only possible to change this toggle during Connect.me installation. For the NHS Staff Access Hackathon, we are using Sovereign Staging Net. We have predefined schemas for the hackathon written to Sovereign Staging Net, and for this reason, we need to turn this toggle to on so that our Connect.me app will be using Sovereign Staging Net ledger for credential issuance and proof verification flows. Now, I will click on Use Biometrics button and register my fingerprint with the app, and will also type in my passphrase in the case that biometric fails, and I'm finished with setting up the app. Now the app is ready to scan QR codes, establish connections, get credentials issued, or share responses to proof requests. We will see how this works in the later sections. Now that you have your Connect.me app installed, you can try out Verity SDK example app. Verity SDK needs to communicate with Verity application server. Verity application server will host an agent that will route messages between Verity SDK and different holders. When you first run your Verity SDK, it will ask for a provisioning token. This is an authorization that you are entitled to create an agent on Verity application server. You will get your provisioning token from INTEROPen site. If for any reason this does not happen, you can go to Evernym Hackathon page, and at the bottom of this page, there is a form where you can request your free Verity access if you are INTEROPen Hackathon participant. You will get access token for Verity SDK, and you will also get REST API keys, which are needed for Verity REST API. From NHS Hackathon page, there is a direct link getting started with Verity that will link you to a page inside Verity SDK repo with instructions how to run Verity SDK example app. And there are two options how to run example app. One is to use pre-built Docker image, which has all pre-requirements installed for all three languages that we support. And the other option is to run example app locally. In this case, you will have to install prerequisites yourself. And prerequisites are libindy library. So Verity SDK packages need libindy library in order to function. And there is another requirement for which we use ngrok tool. And this is because Verity SDK will send requests to Verity application server. And Verity application server will provide responses to Verity SDK asynchronously by sending responses to a registered webhook endpoint, which needs to be served on a public URL. So your Verity SDK will need to serve endpoint, which needs to be reachable from outside, from the internet, from Verity application server. And we use ngrok tool to achieve this in development environment. So when you start your Verity SDK example application, by default, it will listen on port 4000. And we use ngrok tool to map, to create a tunnel between localhost port 4000 and a public URL, so that your Verity application server will send responses to this ngrok public URL, which will then be tunneled to your local application port. If you have capabilities to start Verity example app on a cloud infrastructure, then you don't need ngrok workaround. So in order to be fast here, we will use pre-built Docker image, which has libindy and ngrok pre-installed, and that will automatically start ngrok tunnel in Docker entry point. So let's see how this works. So here I have cloned Evernym GitHub repo with this command. And here inside of Verity SDK repo, I have built Verity SDK Docker image. So the command for this is from the root of Verity SDK project. I ran this command. I will repeat it here. So I'm building Verity SDK image based on the Docker file, which resides in sample SDK folder. And since I've pre-built it before, this is now fast. If you are running it for the first time, it will last several minutes to complete. Now, you can start your Docker container based on Verity SDK image. And as you see, it will start ngrok tunnel automatically and will set Verity application endpoint to HTTPS was pps evernym.com, which is Verity application server, which is created for by Evernym and will be used in this hackathon. So now we can start example app in one of these three languages. So if I go here, ls, or like here, I see that there are three folders. One is for the Node.js example app, another is for Python example app, and the third one is for Java example app. So let's, for instance, choose Node.js example app. And here we will run node example.js. I will start also connect.me on the other side. So when I run node example.js, it will ask to provide provisioning token, and it will prompt me for a token. And here I will paste a token which looks like JSON, which is a JSON which looks like here. So I'm pasting this now here. And then since Docker image has set environment variables for these prompts for Verity application endpoint and for the ngrok webhook URL, it just prints out that it will use this Verity application endpoint, and we need to press any key to continue. This is just like information for us that this Verity application server will be used. Then it creates a wallet. Then also it asks what is a webhook endpoint, what is public URL for local port 4000. And this is also set via environment variable in Docker entry point when the Docker container was started. So we just also need to press enter here. And now a new context is created on Verity application server. A new domain did is created that will new domain for our agent. So this is like a unique identifier for our agent on Verity application server. And then issuer keys are created for our Verity SDK application. And then in order for issuer to be able to create schemas or credential definition, it needs to be registered as a transaction endorser on Sovereign Staging Net. And the application can do this automatically by sending post requests to self-sovereign site for registration of endorser on Sovereign Staging Net. So if I press yes here, that I want my issuer did and work key to be automatically registered as endorser on Sovereign Staging Net, it will send a request, and now my issuer did and work key are registered as endorser. I can also see all response messages that are received on the webhook printed with these signs. So after our issuer keys are registered, then a connection should be established so that we can receive a credential to this connection. So a new connection is created, and this is the invite URL for the connection. And then we need to scan a QR code to establish a connection. And this QR code, you will in the app get printed out a URL from which you can scan the QR code to establish a connection. So if I copy this and paste it in my browser, I will get a QR code that I need to scan with my Connect.me app. And if I now scan it, I'm now scanning it with my Connect.me app. And now I'm coming back to this screen. So I see that there is a new connection pending. So I'm clicking on connect, and connection is established. So now the application is writing a sample schema to the ledger and the credential definition. I see it on the left side. Sample diploma schema. So I'm now waiting for credential definition to be written to the ledger. After this, yeah, I see this. This is done now as a response. After this, I'm being offered a credential based on this schema. Okay, so now it has offered me a credential offer with the values with two attributes, name and degree, with some sample values, Joe Smith and bachelor's. And I'm seeing this on my connected me. So now I'm accepting it. And now, once this is accepted, I will get a proof request on my connected me device. Okay. Um, where we are asked to present our degree and name attributes. And when I click send, the proof will be sent to here. And I'm seeing response, the proof is validated, and these values were returned in the proof response. And so I basically saw the whole flow that I established a connection, I was given a credential, and then the application also requested a proof for this credential from me, and I shared this proof also here. So this is example app in Node.js, and very similarly, if we go here now to a Python folder, we can run Python and then app.py, and then we will get completely same flow where we need to provide the token, then it will establish a connection, create issuer keys, write them to the ledger, ask us to establish connection, etc., etc. Completely the same flow, and also for Java. And you can use this Docker container to get started fast, and you can then examine this example app and make modifications to it and create your own business logic. So this was a showcase how you could start your Verity SDK example app fast and get yourself a credential or proof request. We will now show how you can use Verity REST API to create your issuer or verifier SSI applications. To use Verity REST API, you will need a domain DID and X API key. You can obtain domain DID and X API key needed to use your REST API in the same way that we explained how you could obtain your provisioning token. On the NHS Hackathon page, there is a direct link to tutorials on how to build an issuer or a verifier app using REST API. So for instance, if you click here on how to build an issuer app, we will go to a step-by-step tutorial where we start from a skeleton. You see here in this skeleton how we are sending messages to Verity application server, and in these messages we need to put in the header X API key as a secret, and then there are placeholders for steps needed during credential issuance, like we need to set up issuer keys, to create schema, to create credential definition, then we establish a connection, and then send a credential to a connection. And then later, we explain each of these steps, how you can codify these steps, and in the end, there is a link to a completed application. So this application here is completely runnable once you substitute these placeholders with your values, your specific domain DID REST key, webhook URL where you will receive responses from Verity application server, and address of the Verity application server. Also here, there is a guide how to run this app. Basically, you first need to start a public, start ngrok to create a public URL for your local port 4000 for your application port. Then you need to install required npm packages, Verity SDK npm packages among these. Then you fill in your values and basically you can start your application. So now we will see how this looks like in practice. So here, in a separate terminal, I have run this command ngrok http 4000 to start ngrok tunnel. And in this terminal, this command is running in the background. So ngrok http 4000 command has created a tunnel served on a public URL that will forward all received requests to our application, which will be listening on localhost port 4000. Here in Verity SDK repo, in samples, REST API issuer, we have issuer.js file, which is a completed application. And I have also created two other files, which will represent two different issuers, which I will use in this demo of the functionality. And in these files, I only changed the values for placeholder variables and the schema that I'm using for a credential. So I can show you this. So in Visual Studio, let me compare original completed issuer application and the file that I prepared. So let us examine differences. So here in these placeholder values, I put for the Verity application server this address that we will use for the hackathon, vas.pps.evernym.com. Then I put mine domain did and REST API key. And then for the webhook URL here, I put address of ngrok tunnel /webhook. So you see E90 something. This is the address from the ngrok tunnel. So this is this address /webhook. So I pre-filled these values. And what else did I change? Okay, so in the original issuer app, we are creating a schema, diploma schema with two values, name and degree. To spice up things a bit, instead of using this simple default schema, and instead of creating schema, I'm using one of the schemas that NHS prescribe for this hackathon. And regarding this schema ID that I will base my credential definition on, you can find them also on the NHS Hackathon website. So let us show you. On the NHS Hackathon website, there is a quick link, sorry about this. There is a quick link, predefined schemas for the NHS Hackathon. If you click on it, you will get here a dozen of schemas that are already written to the Sovereign Staging Net with a certain set of attributes that NHS proposed to use for the hackathon. So you see there is like passport schema, national insurance number schema, medical qualification schema, GMC registration, etc. So for your use cases, you're free to use one of these schemas. You just need to paste the schema ID in your credential definition creation command, and you will get a credential definition with these attributes. So I have used these predefined schemas in my issuer REST application. However, If none of these schemas fits your use case, you are also encouraged to create your own schemas and base your credentials on your own schemas. So I have used one of these schemas. Instead of creating my own one, I have reused one of these schemas ID for GMC registration. And you see the later differences. Instead of Trinity College name, I'm using GMC as the name of the issuer and the logo URL. I'm here changing the logo URL that will appear on connect.me. And also, since this credential definition has fields that are defined in this Google Doc that I showed, I need to provide values for a credential that I want to issue for each of these fields. So I have imaginary John Doe and the values for each of these attributes specified in the schema. And then also I'm naming my credential as national. For instance, here I should put something like GMC registration credential. Okay, and these are all the differences. So you see, I didn't touch most of the code at all. I just changed the schema that I will be using and the attribute values and the logo, and I pre-filled here the values for required parameters. So let us now try to run this app. So I put my two issuer apps here, issuer GMC and issuer UKTI. In this other application, I just reused another schema. So in this use case, I want to show how I can send two different credentials to connect.me, and later, from a verifier application, request a compound proof that will ask for a subset of attributes from this credential and a subset of attributes from this credential. So I first need to issue myself two different credentials, GMC1 and UKVI1. So let's start with this. I'm turning on my Connect Me application now. Here, we can also, so we have pre-filled our application that we want to start. We have started ngrok tunnel. Then we need to install npm packages. And then I need to run node issuer GMC application. So here the application starts and it's creating, you see now, credential definition based on the schema that I specified. It will be named GMC registration. And after this, it will ask to establish a connection with the issuer and will send us a credential based on this credential definition. Okay, so now the application has created QR code in its current folder, which we need to scan with connect.me app. QR code is actually a encoded value of invite URL. So you can also copy paste, for instance, this value into QR code generator, and you will get the same QR code that is in this file. So let us now open this created file QR code and scan it with connect.me app. So now I'm scanning it with my connect.me app. So you see now I scanned it and it says, "Hi, GMC wants to connect with you." I'm clicking on connect. Now, since the application received connection response, it offered a credential based on the value we prescribed. And here I see that GMC is offering me GMC registration credential. I'm viewing it and it contains the data we hard-coded in the app for the values. And now I'm accepting it. And basically the demo is completed since the issuer app sent a credential to connect with me. So we also, after a while, yeah, here, you see now that credential is also accepted on connect.me side. I can click on view credential and see all these values. And I can use this digital credential to respond to proof requests. Now, I will issue myself another credential called UKVI credential. And also I can just show you what are the differences. Issuer app, select for compare, and then UKVA, select for compare. So no, sorry, issuer.js, select for compare, and UKVI compare with selected. So I just filled in these values, then used another schema, right to work schema issued by UKVI organization, and then then named my issuer as UKVI, put a proper logo, and then this credential definition has 5 attributes, and I provided here hard-coded values for a credential with these 5 attributes for John Doe, that he is non-resident with temporary visa expiring on this date. And okay, here for credential value, I will put UKVI cred. Okay, and now, so basically we did the same for the other that we did for the other application, but we just need another credential to demonstrate some concepts. So again, here it's creating a credential definition based on this right to work schema that NHS prescribed for the hackathon. After it creates credential definition, it will offer us, it will create a QR code that we should scan with connect.me app to establish a connection. And then it will issue us a credential. So again here, last time we opened QR code, but let me show you that we can also do it otherwise. Let's say we can copy paste this invite URL and in a QR code generator, paste this value, and then scan the generated QR code. I'm now scanning it with connect.me app, and in connect.me app, I'm getting this screen. UKVA wants to connect with you. I'm clicking on connect, after which responses are received here, and immediately on connection response sent, issuer web app is pushing a credential offer to a phone. We see here that UKVI is offering as a cred. We see the values in the cred, and we accept values. And basically, this completes the demo on the issuer side. As soon as it sends a credential here, it takes a few more seconds for the credential to get issued. And basically, we completed the demo, and we now have 2 different credentials in our wallet. And now we will try verifier app, where we will ask for a compound proof, which will require, okay, let me show you. So I have, for instance, now verifier BTH, which is based on the verifier app. So let us first talk about verifier app, which is really similar to the issuer app. It first establishes a connection, and then it is sending a proof for the attributes from the connection. And this is the basic verifier app, where you need to fill in the placeholder values. And here, for the in verifier BTH app, we filled in these values, and we also changed the data we asked for. So we choose to ask for, okay, let me compare, it will be easier. So we change the values and we change the name of the verifier. And then instead of asking for just 2 attributes, name and degree, which could be also self-attested, we are asking for 7 attributes, 4 from the GMC registration schema and 3 from right to work schema. And we are also specifying restrictions that provided proof response must be based on the schema ID, either GMC registration for these 4 attributes or right to work for the last 3 attributes. So here we want to demonstrate a concept that you can only ask for a subset of attributes. So it is so-called selective disclosure. You are not disclosing all the values in your credential, but only a subset of values that are interesting to a verifier. And also, we are demonstrating another concept that you can use multiple credentials in your wallet to satisfy a single proof request. So let us now establish a connection with verifier and get this proof request for these 7 attributes, and let's see how Connect Me App will populate this proof request. So in Connect.me App, I'm going to the main screen. Here I'm changing to the verifier. So now I will say verifier BTA. Okay, I also first need to install npm packages here, since I didn't do it. Just to remind you, in the background we are having ngrok running and directing all the traffic towards this address, our webhook endpoint address, to our local port 4000, where our application is listening for requests. So we don't close this window with ngrok tunnel. Now I'm starting verifier BTH app. And again, it created a QR code which we can scan in the verifier folder. Now scanning this with my Connect.me app, showing you the screen on Connect.me that appeared after I scanned this QR code. Clicking on Connect, this will send response sent message from Connect.me towards our Verity SDK via Verity application server. And now what has happened is that verifier sent to our connection proof requests for these 7 attributes. And let's open now this and Connect.me. So it says that Blackpool Teaching Hospital wants to share the following attributes. Click on view, and you can see that Connect.me app pre-populated these values. And by the logo, you can see that 4 values are populated from General Medical Council credential, and the last 3 values are populated from UKVI credential. So this is completely contrived example. However, I wanted to demonstrate these 2 concepts of selective disclosure and compound proof. So now when I click send, I'm sending response back to Verity application, and here I receive the response that proof is validated and that revealed attributes are this. So Connect.me app send us these attribute values. So this was demonstration how you could quickly build your own issuer or verifier app. You can start from almost complete issuer or verifier app and modify it to suit your needs. By now, we have shown how you could use either Verity SDKs or Verity REST API to create your issuer or verifier application. All of the example apps shown so far were command line based. However, nothing prevents you to build fully fledged web app using Evernym Decentralized Identity Platform. We have created a sample web app to get you started. That sample web app is also built using Verity REST API, so you will need to have your domain DID and X API key. And there are instructions to start web app either locally on your environment or as a Docker container. After you start the web app, you could access the web app in your browser and access SSI flows like connection establishment, proof exchange, credential issuance. On NHS Hackathon site, in developer resources section, there is a direct link to the folder inside Verity SDK repo with the sample web app. In this folder, there are instructions, few steps basically, how to start the application on a local environment, or alternatively, there is README Docker how to start it as a Docker container. So let's say that we want to start it as a Docker container. So we have steps to put in env file, environment variable file values for our Verity application server, our domain DID and REST API key. Then we are building a Docker image from the current folder based on the Docker file in the current folder named demo web app. And then we are starting a container based on that image. And we are passing environment variables specified in the file to a Docker container so that they are available to the application. So here on command line, I have filled my domain DID and X API key in the file. Now I'm building an image. This is fast since it is using cache. I pre-built it before this recording. And now I will start this image. So it will map port 3000 of the container to port 3000 of the host. And let's see, it will also start ngrok tunnel in Docker entry point so that there is a public URL, webhook URL, where our sample web app will receive responses from the Verity application server. So this server will send responses to this URL, which will be tunneled to localhost port 3000. So now on localhost port 3000 or on this webhook URL, you can access your sample web app. Okay, so in the web app, we have several functions. So we can change the name of the institution and the logo, and this will be respected in connect.me. And then we can create issuer keys or retrieve issuer keys if they are already created for our domain DID. So here are our issuer DID and ver key. Then we can create schemas, credential definitions. We can establish connections. All of this we saw before already. We can issue credentials, request proofs, and there is one function that I want to show that is also possible with our technology, and that is committed answer. So once we establish a connection, we can send a specific question, closed form question, to our connection with a defined set of possible answers. And we can then retrieve the answer that connection has chosen. And this has a variety of applications. For instance, once you establish connection, you can ask a connection whether it accepts end user license agreement Another application, for instance, is for two-factor authentication. You can send a question to a connection. Are you trying to log on to this website now? Yes or no? So let's see how this works. In order to send a question to a connection, we first need to establish a connection. Okay, I'm now opening my Connect.me app on the right side. So connection name test. Now I need to scan QR code, my mobile phone. Okay. And now I have established a connection, and this is connection did towards this specific connection. Now I can send a question to this connection. For instance, how was course? And set of valid responses. Let's say, I don't know. And choose a connection to which I want to send this question. And when I click send structured message, I receive here a question from Verity example app. When I click on it, there is a question, how was the course? And I'm having these answers as possibilities that I specified here. And for instance, let's say that I, on my Connect.me device, answer very good. And when I click submit, this will be sent to Verity application server, and from Verity application server forwarded to our Verity sample web app. And it will here appear in the webhook. You can see here all the messages received on the webhook. So we received an answer very good, and signature was successfully validated. And here also in received answers, we see that we got answer very good from a connection to which we sent a question. I won't show the other functionalities like issue credential or request proofs, since you already saw this in the previous recordings. So this is a demonstration of our sample web app, and from here you can access a source code for it. There is basically this file, which is backend of the app, and front end of the app is here in public folder. It is served by Node.js Express. In this index file is actually a front-end logic. It uses Vue.js for front-end. So you can examine both front-end and back-end pieces and, let's say, adopt it to create your own web application. And just to show that, for instance, we have chosen to use Docker, but it's really easy also to not use Docker and to start it locally. And we will just show this piece too. So here, when we started Docker container, we are seeing also all the messages that are posted to Verity application server or that are received from the Verity application server. So we can also analyze how these messages that are being exchanged look like. Okay, so now I will break this. Okay, so now my application is stopped. And let's say I will now just start application using these instructions. So I have Node.js version 12 already installed. Our application listens on port 3000, so I will establish ngrok tunnel in a separate terminal for port 3000. Okay, So this will be our webhook endpoint URL. Okay. Now I need to install npm packages needed by the application. And after this is done, I will start the application, and the application will ask me for these 4 parameters, and that I will need to fill them in the prompt. So it asks for Verity application URL. I can retrieve this from my environment file that I already prepared for the Docker. So Verity URL is this one. It is always the same for the hackathon. Then another question is mine domain did. This is what you will receive from Evernym. And then next question is REST API key. And the last question needed to start the app is webhook URL. And this is the address of the ngrok tunnel that we started for our local host port 3000 where app is listening. So when I pass all these fields, application should be listening on port 3000. And let us check in a new tab. And here I see that the application is working. Okay. So this was a demonstration of sample web app. And that was all that we prepared. Thank you for watching, and we wish you a great hacking experience with the Evernym decentralized identity platform.